All right, so if you can hear me, say what's up, Ferg. All right, so let's start with number one. If we have z equals negative 3 plus 4i and w equals 5 minus 12i, we need to find the midpoint. Find the midpoint, m of z and w, and then find the distance between z and w. All right, so midpoint. Remember, the midpoint formula works x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Oh, wait, that is the midpoint formula for coordinates. What is the midpoint formula for complex numbers? Well, we have our real number 1 and plus my real number 2, and then divided by 2, plus, and then we have our imaginary number 1 plus my imaginary number 2 over 2. So right here, so my real number, negative 3 plus 5 over 2 plus, and then I've got 4. I don't need to put the I. The I sort of hangs on here. So I've got 4 plus a negative 12 divided by 2. And so let's see, that's going to be a positive 2 over 2 plus, that is going to be a negative 8 over 2 with a little I on the side. And so that's going to be 1 plus, oops, not plus, sorry. Come on. What? See, now you make me look bad here. Come on. I think this is another one of those times where folks tell me that I have too many tabs open. All right, so we're going to erase that. And because it's a negative 8, we're just going to say minus 4. So because that's a negative 8, negative 8 divided by 2 is minus 4. So, and there's my midpoint, right? And so now the distance, right? The distance formula works just like the distance formula. I'm going to have the square root, so d equals, I'm going to have the real number 1 minus the real number 2 squared plus the imaginary number 1 minus the imaginary number 2 squared. Now what's important is that I could reverse this as long as I'm consistent. So if I said real 2 minus real 1, imaginary 2 minus imaginary 1. So my real 1 is going to be negative 3. So that is a negative 3 minus 5 squared plus, now my imaginary. So I'm going to have 4 minus a negative 12. It works the same if I reverse them. It would have been 5 minus a negative 3, which will give me a positive 8. Negative 8 or positive 8, honestly, it doesn't matter because the square gets rid of the negative. So I would have had negative 12 minus 4, which would have been negative 16. In this case, it's going to be positive 16 squared. All right, 16 squared, I think is 256. So that's going to be 64 plus 256. So that's going to be 0, carry the 1, 11, 12, 1. So 320. 320 is not a perfect square. But let's see, 320, what perfect squares go in there? 4 goes in there, what, 80? 16, I think, goes in there. Let's see, what else? Was 64 go in there? 64 times 5? Is that it? Yeah, 64 times 5. So I'm going to say that's 64 and 5. So I'm going to take the square root of both of those. What's the square root of 64? Is 8. Square root of 5 stays 5. So my answer for the distance will be 8 times the square root of 5. 5 times 4 is 20, carry the 2. 5 times 6 is 30, plus 2 is 32. See? Don't need that. So there we go. So my distance, D, equals that, and my midpoint, M, equals that. Excuse me. All right, so I'm just going to make these quick. So let's do the modulus of a complex number. So if I have P equals 15 minus 8i, and I want to do the modulus. Well, the modulus is like a sort of truncated distance formula. I'm going to take my real number to the second power plus my imaginary number to the second power. And that's going to be the modulus. So, that's 225 plus, was that 64? That should be 289. And guess what? 289 if you take the square root of 17. So the modulus for that one is 17. What about Q? Q is the square root of 5 minus I times the square root of 8. So I'm going to have the square root of 5 to the second power plus, this is negative, but honestly it doesn't matter because the square is involved, so it's going to knock the negative out. So that's just going to be 5 plus 8 because the square root and the square, they cancel each other out, right? But because this is being squared, the negative also goes away. Negative square root of 8 times negative square root of 8 is positive 8. So then I just have the square root of 13, and that's my answer. Because that doesn't have a perfect square, or I can reduce it. So bada boom, bada bing. So that's number 1 and 2. I'm gonna stop the video right there because I'm having some issues and I got out later than I wanted to. So we're gonna stop right here and I'm gonna do another one.